In this chapter, we're going to talk about the demand and supply model. We're going to think about how to solve for equilibrium price and quantity mathematically, and we're going to be thinking about some other things that go along with that demand-supply model, like the concept of elasticity. So we'll review elasticity, and we'll talk about actually an easier way to calculate elasticity than you're used to. But first we need to review kind of what we mean when we talk about a market, review demand, supply, the determinants of demand and supply. So let's start with a market. Anytime we've got buyers and sellers of a particular good or service, we've got a market. So you can't have a market unless you have both sides, and the definition of a market isn't dependent upon the number of buyers or the number of sellers. So you would have talked about markets where there's only one seller. That's a monopoly. There's also markets where there's only one buyer. That's what we call a monopsony. There are markets with lots and lots of buyers and sellers, like perfect competition and monopolistic competition. And then there are markets where there are just a few sellers, like oligopoly. But at its most basic level, a market is just buyers and sellers of a particular good or service. And we can think about different definitions of the market, broad or narrow. So we could think about the market for gasoline in Kansas City, or we could think about the market for gasoline in a smaller town like Warrensburg. We could think about the market for gasoline in the entire United States, or the world market. So we can think about markets in terms of different geographical regions. We can think about markets at different points in time. So there's lots of different ways to think about it. Let's think about some of the assumptions that we make with this basic demand and supply model. We're going to be thinking about competitive markets. Okay, so we're going to start by thinking about essentially what we call perfect competition, but typically these days we just call them competitive markets. So let's talk about the characteristics of a competitive market. We're going to be thinking about one market at a time. The name that we give that, and it's not important that you remember this name, but we'll talk about it later on in the semester, we call that partial equilibrium analysis. If we start thinking about how one market interacts with other markets and how they might interact between each other, then we're thinking about what we call a general equilibrium analysis. But for right now, we're going to think about one market at a time. We're going to be thinking about markets where the goods are identical. Every buyer is buying the same thing from all the sellers who are selling the exact same thing. There's only going to be one price. Because the goods are identical, all of them will sell for the exact same price. And we're going to be thinking about this in terms of people having full information. A lot of times we don't talk about that assumption in a principles class, but it's important that we think about it in this class because it's necessary for there to be one price. And I'll explain why here in just a second. But all of the buyers know, they have full information about all the places they can buy it at and the prices that other sellers are selling it for. And then there are lots of buyers and sellers. Lots of buyers and sellers. Now, if we think about the implication of these characteristics, how does a competitive market work? What you know is, from your principles class, hopefully you remember that both the buyers and the sellers have no control over the price. So what this means is that buyers and sellers are price takers. They have no control over the price. That's different from, say, a monopoly. A monopoly is a price maker. They get to decide what the price is. They're limited by how much people are willing to pay, but they still get to pick the price. In a competitive market, neither the buyers nor the sellers have any control over price. Now, what I always do in a principles class is I always start the demand and supply chapter by asking students to consider this question: who determines the price of the gasoline that you buy? And I'll have students kind of think about it, and if I ask them to offer up some suggestions for who they think controls the price of gas, I'll get kind of the same set of answers every semester. It'll be things like the government, or it'll be things like the gas stations, or the big gas companies, or the president, or OPEC, or some other country like Russia. They have a whole variety of answers, and the right answer is that nobody does that. Nobody controls the price of gas. It can be influenced by some things like taxes, so the government can influence that price. But that's not what we're talking about. We're talking about who determines the price, and the right answer is that nobody determines the price. What happens is that we've got a demand curve and we've got a supply curve, and those two things come together, and out of that comes a price that neither the buyers nor the sellers chose. Because if the buyers got to choose the price, they would always choose it to be lower. Buyers like low prices. And if the sellers got to choose the price, they would always choose it to be higher. Neither of them gets to choose it. It's the interaction of demand and supply. The way that I try to get students to kind of be convinced by that is to think about how it would work if you were a buyer of something in this type of market. And the example that I typically use in a classroom of students, pretend that you're sitting in a classroom of students, and let's suppose that all of the students in the classroom are selling the same thing. You're selling these blue or these green markers. Okay, so in front of you, you've got a box of these green Expo neon markers. And let's suppose that the price that you have on them is the same as the price that everybody else in the room has on them. It's $1. And we'll review how the price got to $1. It's very basic, but we'll review that here in a second. Suppose the price is $1, so all of you are selling the same good. The goods are identical. You're all selling it for $1. And there's lots of you. There are lots of sellers, and there are also going to be lots of buyers. So I'm going to be one of the buyers. I walk into the room, and I forgot to bring my marker to class today, and so I need to buy one. So I start to walk up to you, and you see me coming, and you think, oh, here comes Dr. Azevedo. I'm going to gouge him a little bit. And so as I walk up to you, you say, oh, just had a price increase. My pens are now $1.50. Think about what I'm going to do. Am I going to say, oh gosh, boy, that's a bad deal. Okay, well, here's $1.50. Well, of course not. I'm just going to go to the person next to you, and I'm going to buy the exact same pen for $1. And then as I take my pen away for $1, I'm going to look at you and wink at you and say, hey, man, you don't get how this is working, do you? Because if you're selling the same good as what everybody else is, you can't charge a higher price. Not as long as the buyers have information about places they can get it cheaper. So if you try to raise your price above the equilibrium price, you're not going to sell anything. Now let's think about, so now we know why sellers are price takers. Let's think about how we know buyers are price takers. Suppose I walk into the room and I see you sitting there with your box of pens, and I think, oh, I'm an economics professor. I know more about how markets work and all of that kind of stuff than this person does. So I walk up to you and I say, hey, I need to buy a pen, but I'm only going to give you 50 cents. Think about what you're going to do. Are you going to sell me a pen for 50 cents? And sometimes students will say, well, okay, selling a pen for 50 cents is better than not selling a pen at all. So yes, I will sell a pen for 50 cents. But that's a false choice. That's not the choice that you have to make. Your choice isn't to sell me a pen for 50 cents or not sell one. Your choice is to sell me a pen for 50 cents or sell the next customer in line the same pen for $1. And so why would you ever sell it to me for 50 cents when there are lots of other buyers with $1 in their hand ready to buy that pen. So what that means is no buyer has any bargaining power in this type of market. And if you don't believe me, then what you need to do is you need to get in your car, drive to a gas station, look at the price up there on the sign, and then walk in and offer them something less than that. Say, I see that you're selling gas for that price out there, but I'll give you 50 cents less per gallon. See what they do. See if you can kind of price gouge them. I guarantee you can't. They're just going to tell you to get your car out of the lot so that somebody else can pull in there and buy gas. So neither the buyers nor the sellers have any control over price. Well, that doesn't leave anybody. If it's not the buyers and it's not the sellers, then that means nobody determines the price of gas. It's determined in a market. And again, we'll get to exactly what the mechanism is here in a second. But now we've got one of the key outcomes of this type of market, and that is that buyers and sellers, neither of them have any control over the price. They are price takers. Let's think about focusing on demand first. So let's start by thinking about a review of how kind of the theory of demand works. We know that the number of units that you want to buy is determined by, in part, by the price of the units. So we know that there's an inverse relationship between price and quantity demanded. So when we have an increase in price, when we have price going up, then that will lead to a decrease in quantity demanded. QD is the way that I'm going to designate quantity demanded. And the opposite of that is true. If we have a decrease in price, we know that that's going to lead to consumers wanting to buy more of the good. So when price is low, you want to buy more. When price is high, you want to buy less. All other things equal. If we think about why does that happen? Well, in your principles class, you would have learned that the reason that that happens is two things. The first is what we call the income effect. Income effect. Let's think about it in terms of an increase in price, because these explanations are easier to think through in terms of an increase in price. So let's start there. If the price of something you buy goes up, then that has an adverse impact on your income. So if you think about a big increase in, say, the price of gas, well, you're going to have to spend more on gas, and that leaves less dollars left over to spend on other things. It's like getting a cut in your income. And because you've got a cut in your income, you buy less stuff, including less of the thing whose price went up. Now, here's the one exception to that. You already know that there are some goods that we call inferior goods. And for an inferior good, when your income goes down, you tend to buy more of them. That's the one exception to the income effect, but most goods are normal goods. And so when your price goes up, it has a negative impact on your income and you tend to buy less. So that's the income effect. There's also what we call a substitution effect. And what that says is that when the price of something you buy goes up, other things become cheaper in comparison, and you tend to substitute towards those other things. So for both of these effects, at least for normal goods, an increase in the price will cause you to buy less, and a decrease in the price will cause you to buy more. What we'll see later on in the class is that the substitution effect is always bigger than the income effect. And so we can say that these relationships hold all the time. As a matter of fact, we've given it a name and we call it the law of demand. Law of demand says that when price goes up, quantity demanded goes down, and you hopefully remember that the law of demand just simply tells us that demand curves slope downward. Actually, it doesn't quite say that. What it really says is that demand curves never slope upward. You hopefully remember that you can have a demand curve that is horizontal, and we can have a demand curve that's vertical. We can have perfectly elastic or perfectly inelastic demand curves, but we're never going to have an upward sloping demand curve. Okay? So that's the law of demand. Let's talk about the determinants of demand now. Determinants of demand. These are the things that shift demand curves. So let's briefly run through those. The first one that we're going to think about is income. When your income changes, that will cause your demand for different goods and services to change. And we've just talked about the fact that most goods are normal goods. A normal good, those are goods for which when your income goes up, your demand for them goes up. So for most goods that you buy, if you were to get an increase in your income, you would tend to buy more of those goods. We can think about inferior goods. An inferior good is a good for which when your income goes up, you tend to buy less. When your income goes down, you tend to buy more. So these are the ones that can be a little bit challenging for students because it's a little bit counterintuitive. But here, if I were to ask a student, a class, to give me examples of inferior goods, the first one, almost every semester that I've been teaching, the first one that somebody suggests is ramen noodles. For most people, ramen noodles are probably an inferior good. As your income goes up, you tend to buy less ramen noodles. If your income goes down, if you're trying to get by without spending very much money because you don't have much money to spend, then you might look into eating ramen noodles. There are lots of others. There are things like public transportation, used clothing, generic goods, things like that. The key here, though, is to keep in mind that whether or not a good is inferior or normal is a characteristic of your preferences. So if you were to go to New York City and look at public transportation, you would see that public transportation is not an inferior good for many people in New York City. There are many people with high incomes that ride public transportation. So it's and there may be people out there that maybe collect used clothing or are really into used clothing, older clothing. And so for them, if their income goes up, they'd buy even more used clothing. So it's not the case that whether a good is normal or inferior is a characteristic of the good, it's a characteristic of you. And your preferences can be different from other people's preferences. So income is one of the most important determinants of demand. Another one that we need to think about, prices of related goods. Prices of related goods. So if you think about any good or service, there are going to be other goods or services that are related to that good. So you might think about goods that you tend to consume together, jointly, like peanut butter and jelly. Those would be things that we describe as complements. Complementary goods. Okay. There are also goods that we describe as substitutes. Those are goods where you consume one or the other. A good example of substitutes would be Coke or Pepsi. It's not the case that people go to the store and they buy a Coke and Pepsi, and then when they consume them, they pour them both into the same glass. You consume one or the other. And you might have a preference. You might like one a little bit more than the other. But those are goods that are substitutes. Whereas if we're talking about complements, we could think about something like hot dogs and hot dog buns. Right? You tend to consume those things jointly. Now let's think about how the price changes work if we're thinking about substitutes. If we're thinking about substitutes, those are goods for which an increase in the price of one good increases your demand for the other. So if there's an increase in the price of Coke, people will buy less Coke, and that increases demand for Pepsi. Or if there's a decrease in the price of one, then that will decrease demand for the other because people will shift away from the other towards the one whose price is going down. With complements, it works differently. With complements, if you have an increase in the price of one, people will buy less of that, and that will reduce demand for the other. So if the price of hot dog buns goes up, that will reduce demand for hot dogs. Even though nothing about the hot dogs themselves is changing, a complementary good is getting more expensive. Or if the price of hot dog buns goes down, that will increase demand for the hot dogs. Okay? You have to remember how all of these things work, and if as we're going through this you are a little bit, you've forgotten some of this or you'd like to review, if you'll go to YouTube and look at my YouTube channel, I have principles level videos on all of this, and that would be good to go back and review those if you're not sure about some of this stuff. That's the second determinant of demand. The third is your tastes or your preferences. Okay. So this one really kind of doesn't need a lot of explanation. If people all of a sudden start to like something better, then demand for that will go up. And they could start to like it better because it's being advertised a lot, or maybe there's a medical study that says that this is good for you, or maybe a medical study that says it's bad for you. If that happens, we see demand for that tend to decrease. So your tastes and preferences, we don't really go in economics, we don't go into much depth about why your tastes change. Really, some of the most interesting research into tastes and preferences is done in the psychology field, which is in a lot of ways related to what we're doing in economics. So we're just going to kind of leave that one as it is. Let's go to the next one, and that is your expectations. So these are going to be expectations of buyers. So if buyers expect something that they buy to get more expensive in the future, then they might decide to stock up now. So if you expect the price to go up, that might increase your demand right now. Or if you expect your income to change in the future, that could change your demand now. Okay? So expectations of future price or expectations about future income, those can have important impacts on your demand right now. And then the last one is going to be the number of buyers in the market, or the number of consumers. Let's just write number of buyers. So if the number of buyers in the market goes up, then that will increase market demand. If the number of buyers goes down, that will decrease the market demand. So what we know is that demand curves tend to look like this. Okay? And we're going to talk in depth later on in this class about why demand curves look like that. In a principles class, we would just leave it with the income and substitution effects. But we're going to go into quite a bit of depth about why the demand curve looks like this, and we'll actually graphically take a look at what the income and substitution effects look like later in a future chapter. What I need to do now is clear this off, and then we'll start thinking about kind of the math behind a demand curve. Let's take a look at what a demand curve looks like if we represent it mathematically. So let's draw a picture of this price quantity space that we're going to be thinking about. So we've got price up here, quantity down here. Normally we would just draw a line, a downward sloping line, to represent a demand curve. But what I want to do now is to think about being very precise about how we draw it. So let's break up our vertical axis into dollars here. Let's go up to 5. And our horizontal axis, let's break up into units of 100. Up to 500. So here's 100, 200. And don't worry about the fact that the scale of my horizontal axis is not the same as the scale of my vertical axis. That doesn't matter. Now let's suppose that we've got a demand curve that starts right up there at our 5, right there. And let's suppose it goes down $1 and over 100 units, down $1 over 100 units. By the time it's gone down $5, it would have gone over 500 units. And so if we were to draw each of those points, it would end up being a linear demand curve that comes right down there. Doesn't quite look linear, but close. Pretend that that's a linear demand curve. We're going to call that D. And what we've done here is essentially we've been precise. If we had a piece of graph paper and we had been very precise, then you'd see that these match up just like this. So there's a demand curve. Now that we've been precise about how we draw it, now we can think about what the functional form of that demand curve is. And so let's pull off the vertical intercept and let's pull off the slope, and let's just figure out what the functional form looks like. Now, the way you write the functional form is whatever you've got up here on the vertical axis, then you write P equals, okay? You're probably more used to thinking about a picture where you've got X here and Y there, and that's fine. And if we were to write the functional form for a line that we had there, we would start it with Y equals mx plus b. So it would look like that. There's the slope-intercept form of the line. The b is our vertical intercept, and the m is the slope. So let's do that with this picture. We can easily pull off the slope. We can just look at this point and that point, and we can look at the rise, and we can look at the run. So if we were to start here, this has a negative slope, obviously. So if we go down 1 over 100, our rise is 1, our run is 100. So our slope is negative 1 over 100. That's m. Now, what you do then is you just multiply that slope by the other variable. So that's q. And then we've got our intercept. And our intercept here, our vertical intercept, is 5. So right there is the functional form for that demand curve that we've got up there. Now, normally I would write this way. P equals 5 minus q over 100. These two things are exactly the same. All I've done is I've reversed the order of this, and anytime you've got 1 over 100, you can just multiply, and it's multiplied by something like q. You can just move the q up there in the numerator. Okay, so this term is equal to 1 over 100 times q. If, for example, the slope was instead of 1 over 100, let's suppose it was 2 over 100, and I realize I can reduce that, but I don't want to do that yet. So if I had that multiplied by q, 2 over 100 times q, that would just be written as 2q over 100. Okay? So here's the functional form for this line that we've got right there, for that demand curve. Now, let's talk about what I've been calling a demand curve. If you've had your principles of micro class, and you've probably had a principles of macro class, and you've seen lots and lots of demand curves, well, it turns out that this thing that we've been drawing up here and we've been calling it a demand curve, this actually isn't the demand curve. This is actually what we call an inverse demand curve. Inverse demand curve. Let's think about why. And it has to do with the story that we tell in terms of how you respond to prices. So if you think about when you go to the store and you buy stuff, let's say you go to a store like Walmart, and you're walking through Walmart and you're deciding what to buy, the decision that you make is that you are observing all of these products, and then you're looking at the price and you're deciding whether to buy it or whether to not buy it. Or maybe if you're deciding to buy it, then you look at the price and you decide how much to buy. But the way that you make the decision is that you look at price and then you decide how much to buy. P comes first and then Q. Well, if we look at this picture, the way that you learn algebra is that you think about, let's just draw some function here. Let's make it, it doesn't have to be a line. We've got some curve there. The way that you think about it is that you pick an x like this and you plug x into that function, and out of that pops a y. So if this is x1 and you plug it into the function, out of that comes y1. And y here is just some function of x. That's how we think about it. You pick the x, that comes first, and then when you plug the x into this function, that tells us what y is. Well, notice that that doesn't fit with the way we've written this function. If this was treated the same way as that, then we would pick q first and plug q into our function, and out of that would pop p. But that's not the story I just told you. It's not the way we think about human behavior. It's not how human behavior works. So what we've got to do is we've got to invert that demand curve. We need to solve that thing for q, and then once we solve that for q, then we'll get a function that has p over here on this side and q by itself, and then that fits with the story we tell. Now here's what we're doing there. When we do that, what we're doing is we're inverting a function. And when you invert the function, essentially what you're doing is you're taking this picture and you're flipping it around. You're making the horizontal axis the vertical axis. You're inverting it. And that puts q up here. So if this is what you've been seeing your entire history of your education in economics, then you haven't really actually seen a demand curve, because a demand curve is drawn in this space. It's got q up here and it's got p down here, and it's still downward sloping. If you take this picture and you invert it, it's still going to be a downward sloping line. But now this picture fits with the story we tell, because now we can pick a price and we plug that price into the demand curve, and out of that comes the quantity demanded. If that's P1, then there's Q1, and now that is a demand curve. Okay? A demand curve has Q on the vertical axis and P on the horizontal axis. If you were to go back 100 years, and you were 100 years ago sitting in an economics class, we never would have drawn this picture. We would have drawn this picture. But then a textbook was published, I believe it was published by Alfred Marshall, early in the 1900s, and what Marshall did was he flipped things around. He made his demand curves with P up here and Q down there. And his textbook was very popular. It became the most popular economics textbook. And from that point on, we've been drawing our demand curves with P up here and Q down there. And it's not a problem if you think about it mathematically. But it is a problem if you think about the story, because the story doesn't make sense. You don't look at the quantity first and then out of that pops price. That's not how we behave. We don't get to choose the price. What happens is we observe price and decide how much we want to buy. And so this is the more accurate way to think about how demand curves work. So this is the demand curve. This is an inverse demand curve. Okay? Now all you have to do to get the demand curve, if you're starting with this, is you just simply invert it. So let's do that. P equals 5 minus Q over 100. So what I'm going to do is I want to solve for Q by itself instead of P. So the first thing I'm going to do is I'm going to move I like to have the thing I'm solving for, I like to put it over here on this side, on the left side. So I'm going to move this over. So Q over 100 is equal to 5 minus P. All I did there is I reversed where these two terms were. I moved this one over, subtracted it from both sides, and I moved that over, added it to both sides. But now I need to get Q by itself, which means I need to multiply by 100 to cancel that 100 in the denominator out. So that gives me Q. If you're multiplying this term by 100, you've got to multiply every term by 100. So this gives me Q equals 500 minus 100P. That is the demand curve. Anytime you're talking about a demand curve, you're talking about a function that is solved for Q. If you're talking about the inverse demand curve is always solved for P. But now this one is consistent with the way human behavior works. If we know the price in the market, we can plug that price into the demand curve, and that tells us how much the consumer is going to buy. Okay? So we've got our, now we know the difference between our demand curve and the inverse demand curve. Again, this relationship between price and quantity is the exact same as this relationship between price and quantity. You can take a price and you can plug it in here, or you can plug it in there and solve for Q, and you'll get the same Q if you start with the same P. These are just two different ways of thinking about it. But now we have to think carefully about it, because we've got this story, this behavioral story, and we want to be working with the demand curve, the function that fits with the story that we're thinking about. We've got a name for this term right up here. That term right there we call the choke price. So the choke price, that's the price at which demand gets choked off to nothing. So if you look at prices down here, at these prices, quantity demanded is positive. But as we increase price, quantity demanded is falling. And if we were to look at the quantity demanded at a price of 6, it would be 0. At a price of $5.01, quantity is 0. So that's the choke price. You can get the choke price by looking at the P, the price intercept. You can get it from right there. Notice that if we invert this demand curve, let's take this and draw this. Okay, let's draw this function. Because it's got Q by itself, that tells me that Q is up here on our vertical axis and P is down here. My vertical intercept is 500. And my slope here is negative 100 over 1. So that means I go down 100 over 1. Down 100 over 1. By the time I've gone down 500, I've gone over 5. So here's what this thing looks like. And hopefully you can see that this picture is just that picture inverted. These two pictures are the inverse of each other. If I were to take this and flip it back over, I would get that picture. Okay? So if we're thinking about this choke price, we can get the choke price by looking at the intercept on the p-axis. That would be right here if you're looking at the inverse demand curve. It would be right here if you're looking at the demand curve. Right there is our price intercept. There's another way that you can figure out what the choke price is, and that is just plug in Q equals 0, because that's really what the choke price tells us. It tells us at what price does quantity demanded get choked off to 0. Well, if we plugged in a quantity of 0 into this, put a 0 right there, that term falls out and you just get P equals 5, which is exactly the choke price. You can plug it into this, our inverse demand curve. You can plug it into the demand curve. If you were to plug in 0 right here and then solve for P, you will get P equals 5. So now we know what a demand curve looks like. We can think about a demand curve graphically, but that demand curve is going to be something you probably haven't seen before because it's got Q up here. It's still downward sloping, which is the really important part of a demand curve. And here's what the function looks like. What you're used to thinking about is an inverse demand curve, where we've got P up here, and P is solved by itself. But you can work with either one. What we want to do now is talk about a shift in the demand curve. And so let's think about how we're going to adjust the functional form for a demand curve if demand shifts. Now, in a principles class, we would just talk about maybe income going up and demand increasing. But now we're going to be very precise about how much demand changes. So here's what these would look like. Let's suppose demand increases such that consumers want to buy 100 more units, want to buy 100 more units at every price. Demand increases such that consumers want to buy 100 more units at every price. So let's think about what this looks like actually in this picture. An easy way to think about it is that if demand increases such that consumers want to buy 100 more units at every price, then we could take this price of 1. We know that they want to buy 400 units before the demand increases, but after the demand increases, they're going to want to buy 500 units. So that's going to be a point on our new demand curve. At a price of 2, they wanted to buy 300. Now they're going to want to buy 400. At a price of 3, they used to want 200. Now they're going to want 300. So you can see that it moves over the demand curve. At every point, it moves it over 100 units. If we look at this picture, at every price, it's going to move it straight up 100 units. So at a price of 5, they wanted 0, but now they're going to, I'm going to put over here 400, 300, 2, 1. So at a price of 5, they wanted 0, now they're going to want 100. So it's going to move it up. At a price of 4, they wanted, no, got there. This should be right there. At a price of 4, they wanted 100 units, now they're going to want 200 units. At a price of 3, they wanted 200, now they're going to want 300. You can see that what this does is it moves it straight up by 100 units, straight up. This one moved to the right by 100 units. The easiest way to do it, though, if you want to mathematically figure out what effect this has, is simply to take the demand curve and simply change the intercept of the demand curve. Because what we see here is that the intercept of this new demand curve is going to now be 100 units higher than it was before. So the new demand is going to be Q equals 600 minus 100p. Notice that the slope doesn't change. It's just the intercept of the demand curve that changes. So to show the impact of a change in demand, you change the intercept of the demand curve by however much demand changes. You don't want to change the intercept of the inverse demand curve, because if you added 100 units to this, your new intercept would be 105. It'd be way up there. You can see that the intercept here is going to change, and you can probably tell that what it's going to change to is going to be 6. And if you take this inverse demand, or this demand curve, and invert it, you will get P equals 6 minus Q over 100. So what you want to do is change the intercept of the demand curve by whatever amount I change demand by. Okay? What we need to do now is clear this off and then take a look at what supply looks like. So let's do the same thing, only let's do it with the supply curve now. So we'll think about first quantity supplied. So now, if we're thinking about the other side of the market, we know that sellers like high prices. So an increase in price is going to lead to an increase in quantity supplied, and a decrease in price will lead to a decrease in quantity supplied. Remember, quantity supplied is just the number of units that sellers are willing and able to sell. So if price goes up, if they can sell them for more, then they're going to want to sell more units. We'll talk about that, but you hopefully remember from your principles of micro class that the supply curve, at least for a competitive firm, is the marginal cost curve. And that hopefully helps you understand why this relationship holds. But we'll review that in this class. So that's the law of supply, that price and quantity supplied are positively related. Graphically, what this looks like is that if we draw a supply curve like you're used to seeing, they're going to be upward sloping. But you may have a sneaking suspicion that I'm about to tell you that that's not a supply curve, and that's correct. That's actually not a supply curve. What you're used to thinking about a supply curve is what we actually call the inverse supply curve. The supply curve actually has Q on the vertical axis. Okay? So before we get to that, let's review the determinants of supply. Determinants of supply. So these are the things that cause supply curves to shift. These are the things that are important to firms. The first one that we typically talk about, input prices. So the inputs are the things that the firms use to make the goods and services. So if input prices go up, then that's going to shift the supply curve to the left. And you should remember that if input prices go up, that causes, in this space, that causes our marginal cost curve to shift up, which is the same as a leftward shift of the supply curve. A decrease in input prices increases supply. Also technology, that's an important determinant of supply. But what I like to point out to my students is that this one is exactly the same as that one. So if you think about what it means for technology to improve, if I were to ask you to describe what a technology improvement is, probably one of the first things you'd come up with is you'd say, well, a technology improvement means that we're more efficient. But I would probably say, okay, well, what does it mean to be more efficient? And if you thought about it long enough, you'd probably say, well, that means that we can produce the good with less of the input, which is exactly the same as input prices going down. Our cost of inputs have declined. We can produce the same unit of output with less inputs. So a technology improvement is the same as a decrease in input prices. Now, just because they have the same impact doesn't mean that it's not useful to break them apart and talk about them separately. So that's why we do. So technology is the second determinant of supply. The third one, we'll think about the expectations of the sellers. Expectations of sellers. So if firms expect their price to be higher in the future, they might decrease supply now so that they can sell more later on when price is higher. Or if they expect their input prices to change, they might change their supply now depending upon how they expect their input prices to change. Keep in mind, and this is also true with buyers, their expectations could turn out to be wrong. That's not what's important here. If we want to understand their behavior and what's driving their behavior now, it's determined in part by their expectations right now, whether their expectations are right or wrong. A fourth thing that we can think about is some textbooks call it the seller's outside options. Seller's outside options. This just simply means the other things the seller can do, the other things the seller can sell. Another way that some textbooks describe this is price of substitutes in production. This simply means that any seller typically can sell multiple things, and if one thing becomes more profitable to sell, they may decrease the supply of other things that they sell to focus more on that one thing that has become more profitable. So this is very similar to the prices of related goods for consumers, only here we're talking about sellers. And then the last one is the number of sellers in the market. Number of sellers in the market. So those are the things that shift supply curves. Okay. Now what we want to do is think about the supply curve. Here we've got a supply curve. The law of supply tells us that the supply curve is upward sloping. You know that they can be perfectly inelastic or perfectly elastic, but typically supply curves aren't downward sloping, although you may be aware that there are some times when a supply curve, in the case of what we call a decreasing cost industry, a long-run supply curve, market supply curve, can actually be downward sloping. We'll talk about that later on in the semester. So there's our supply curve. Let's talk about being precise with how we draw that supply curve. So let's do the same thing that we did for our demand curve. Let's start with this picture and let's put, say, prices up to 5. I don't think I've got them spaced out quite right. Let's put 5 up there. And then let's put our quantities out by 100. I'm going to stop at 400 because for this supply curve, that's the only one that we're going to need. We're not going to need the 500 one. The reason is I'm going to start my supply curve right there. There's going to be a range of prices over which the firm wants to sell none. And then let's suppose if price is 2, they want to sell 100, so there's a point. If price is $3, they want to sell 200, so there's a point. Price is $4, they want to sell 400, and if price is $5, they want to sell 500. And so we've got this line right there. We're used to calling that a supply curve. Let me put some dashed lines here just so that you can keep in mind how they match up with each other. There's our supply curve, or at least what you've known as a supply curve up to this point. Let's start by thinking about the functional form of this. Now we've got P up here on our vertical axis, so when we write the function, we're going to start with P. P equals, I'm going to start with my intercept this time. My intercept is 1, and then I'm going to have plus the slope multiplied by Q. Now this is positively sloped, so I know it's going to be plus. My slope, my rise is going to be 1 over 100. There's the functional form for that line. I'm going to write it like this. P equals 1. Let's rewrite it. P equals 1 plus Q over 100. There's the functional form. Now this is an inverse supply curve. It's my inverse supply curve. The supply curve has Q on the vertical axis, and so all we need to do to get the supply curve is we can graphically invert this, or we can just invert this function. Let's do them both. Let's graphically invert it first. So now when I invert this thing, I'm going to have P down here, Q up here. P goes up to 5. Q goes up to 400. This thing starts right here at a price of 1, a quantity of 0. If we go price of 2, quantity is 100, so there's a point. Price of 3, quantity is 300, there's a point. Price of 4, price of 3, quantity was 200. Price of 4, quantity is 300. And at a price of 5, quantity is 400. Right there is the supply curve. And these things match up just like this. And you can verify that what I've got is simply the inverse of that picture. It's still upward sloping. Now let's invert this thing. I'm going to take P equals 1 plus Q over 100. And I'm simply going to solve for Q. I'm going to do this by subtracting 1 from each side. So P minus 1 is equal to Q over 100. Okay, all I did was move the 1 to the other side. Now I'm going to reverse everything because I want my Q to be on this side. So I'm just going to simply reverse the sides. I'm also going to, when I put these two things over here, I'm going to reverse their order. Minus 1 plus P. That's the same as P minus 1. I just changed the order. I'm going to multiply by 100. I get Q is equal to negative 100 plus 100P. There is our demand curve. Now, here's what you want to be careful about. You don't want to let this negative 100 confuse you. A lot of times it's common in my class for students to be working with this supply curve and to, I've got demand written there. There's our supply curve. It's common for them to see this supply curve and to see that negative 100 and think there's some kind of mistake. But that's the vertical intercept, and you can see that what's happening is this thing comes down here and hits at negative 100. We only pay attention to the part of the supply curve that's up here. But when you look at the functional form for the actual supply curve, it's typically going to have a negative intercept. Okay? Don't let that bother you. We can also talk about the choke price. The choke price for this supply curve would be the price below which quantity supplied is choked off to 0. And for this particular inverse supply curve, the choke price is $1. You can get that by just entering a Q equal to 0 into this, or if you add Q equal to 0 into that. If you put a 0 right here and then solve for P, you'll get P equals 1. Our choke price is right there in this picture. So now we've got a demand curve and we've got a supply curve. Let's talk about shifting supply curves. Okay? And we're going to do it exactly the same way that we did with a demand curve. We could think about changing the intercept of the actual supply curve. So to shift the supply curve, to shift supply, change the intercept of the supply curve. Change the intercept of supply curve. Don't change the intercept of the inverse supply curve. Change the intercept of the supply curve. So if we were to think about, suppose I gave you an example like we did with demand. Let's suppose that supply changes such that sellers want to sell 100 more units than before. So supply increases by 100 units. Then we're going to take this supply curve and we're going to increase the intercept by 100. Now the intercept is negative 100. If we add 100 to that, our intercept becomes 0. So our new supply curve would just be Q equals 100P. In this function, the intercept is 0. We could write this as Q equals 0 plus 100P. So when you don't see the intercept is 0. If, let's suppose that we had a change in supply and I said suppose supply increases such that sellers want to sell 200 units more than before. If we're starting from this point, then, and we added 200, then it would be Q equals 100 plus 100P. Okay? So you do a change in supply exactly the same way that you did a change in demand. You change the intercept of the supply curve. Okay? Don't change the intercept of the inverse supply curve. What we need to do now is we need to think about market equilibrium. So what we're going to do is we're going to end this video here, and then in the next video we're going to think about putting this together and then actually setting demand curves and supply curves equal and solving for the equilibrium price. So that'll be in part 2 of this demand supply chapter.